All right. We're going to go through the definition of a derivative first. And you'll be happy to hear that on the AP, you tend not to have to use the definition and actually do the derivative the long way. You have to be able to understand that the definition's there. So, here we go. Definition of a derivative. So you get that actually, let me start with f prime. F prime of a is equal to the limit as h goes to 0 of f of a plus h minus f of a all over h. Okay? Wow, this pen. So, given that, when you see it, you have to understand that that's the definition. When you don't understand that, it makes the problem a lot harder. I'll get it on. I'll find something. All right, so here's my example. It's going to be a multiple choice question, and then you're going to see something like this. Let's see. Not f of, wow. So you'll see this, and you'll see a bunch of answer choices that are numbers. Okay? Now, given that you knew the sum and difference formula for sine, you actually could do this problem by simplifying. Most of your difference quotients, we simplified most of them. In this case, I don't want you to have to memorize extra rules. So I never reviewed the sum and difference rules for trig because you can do without. So how do we do it without? It's very specific. What I want you to do, I want you to look for that h value. And whatever's being added to it, that has to be the a value. So first thing is that this has to be the a value. So I know that a is pi over 6. When you guys are taking your quiz, I'll turn on the air. Okay? I know by looking at it then, this is an input. So the whole thing, the whole set of parentheses, I want you to replace it with x. So that whole set of parentheses, you replace it with x. What you just found was the function. So what's the actual question it's asking you? What was in the front? Whose definition is it? F prime. So it's asking you to find the derivative at pi over 6 of the function sine of x. Way easier than having to use the sum and difference formulas because they're not given on the AP test. Anthony. Oh, you're just yawning? All right. We good? So why do I make you focus here? Because this actually is the sine of pi over 6, but they don't write it. They evaluated it and give it as a number. So this doesn't help you. It doesn't tell you what's going on. This is what's going to tell you what's going on. That can't be simplified. It'll always be a number plus an h. You can't simplify that, so it'll always be there. Okay, that's the shortcut. So obviously the answer would be derivative of sine is cosine of x, so you're finding the cosine of pi over 6, so the physical answer, root 3 over 2. All right, we good? Makes it a lot nicer that you don't have to do that long process every time. The other thing, which I forgot to do for the other class, was give you the other definitions. There's also the limit as x goes to a of f of x minus f of a all over x minus a, and that's still the same thing. That's the derivative at a. Okay? And then there's one other which we don't really talk about much at all, but it's how your calculator finds n deriv. Your calculator does this for n deriv. So you'll see that one. If you remember where the definition comes from, it's the slope between 2 points. Every single one of them. This is the slope between the point x equal to x and x equal to a. That's the interval. This is the slope between the point x equal to x plus h, or a plus h, sorry, comma a minus h. You're just finding the slope between the 2 points and using function notation. So, all right, that's done. Let's look at differentiability then. So I'm going to clear this so don't go crazy copying. you have a clear page button? Alright, so I did not mean to do that. Suddenly I've forgotten everything I wanted to do. Alright, so differentiability. First thing I want you to deal with is the fact that there are different types of differentiability. We're going to focus on one of them more than the other because it shows up a little bit more. The first one that you really want to think about is your corner. Okay? Focus. Your corner is when you take the derivative from one side, so let's say the derivative from the left side, towards some a value, meaning an x, and then you go towards the right side, or from the right side, and those derivative values are not the same, but the left and right derivatives are numbers, meaning not infinity. So that's usually what makes your corners. Okay? That's essentially the definition you guys end up getting stuck with. So the next one is your cusp. So your cusp looks like this. So you should be able to tell that the derivative, right now, the derivative, is it a positive derivative or a negative derivative? Negative. But then if I keep going like this, it becomes negative infinity. When I come from this side, is the derivative positive or negative? It's positive, but if I keep getting steeper, it goes towards positive infinity. So a cusp, specifically speaking, is where your f prime of a approaches different infinities. My easiest way of writing it for you. From each side. The function for a cusp is x to the n, where n is equal to a even over odd that's less than 1. I actually guess I should put 0 is less than. So let me put that into, I'm going to actually do a new statement for that. So n is between 0 and 1. Okay? All right, so that's a corner, that's a cusp. We're going to go to a vertical tangent. So number 3. Not to get confused with, what do you think most people confuse that with? A horizontal tangent? That's one thing. It's actually an infinite discontinuity. For some weird reason, everyone gets it confused with that. Stop staring at the wasp. My gosh. All right, vertical tangent. So your derivative from the left, that's nice to know. Approaches different. If you don't stop staring at that thing, I'm going to make it attack you all. Different infinities. Oh no, see, now you got me all confused. Different, same infinities. Okay, so coming from the left side, notice that the slope is positive, but it's getting steeper. Okay, that's positive infinity. Notice over here is still positive, getting steeper, still positive infinity. So left and right derivatives are positive infinity for this one. If it slopes downward, it'll be both negative. Then we know that the derivative, okay, so we know that cusp is even over odd. A vertical tangent is odd over odd, but same rule, you want n to stay between 0 and 1. 2/3, 1/3, 1/9, those are the powers that you usually saw. And there's one more here. One more non-differentiable point. What's the other way? Cusp, corner, cusp, vertical tangent, there's one other way. Discontinuities. All of them. Every single discontinuity, and how many are there? 4 of them. Okay? All of those are not differentiable. If you're not continuous, you can't have a derivative. So, given that, I want to talk a little bit about using piecewise functions real quick. Yeah, we're good. Alright, so f of x is equal to x squared plus 1, or sorry, x squared plus 2x plus 1. Using easier problems. And the question is f of x differentiable? What that's asking is is there anywhere where it's not differentiable? That's really the question. X squared plus 2, is there anywhere on that curve, if that was the only curve here, that would be not differentiable? No. Same thing with a line. We're differentiable everywhere. So the only place will be the break. So we're going to check at x equal to 1, but there's a two-step process. First thing you have to check if it's continuous first. Because if it's not continuous, you can't even check for differentiability. So to check continuity, you're going to take the y values. So the y value of the top part, check if it's equal to the y value of the second part. And what you'll notice is we get 3 equals 3. So yes, it is continuous. And then after that, what do you check now? Now you check your slopes, which is you actually physically checking differentiability. Same concept. You're not going to use your limit definition anymore. You're going to take a shortcut. Slope of this guy would be 2x. Slope of the tangent line on the right side, 2. And you're doing it at x equal to 1. So we get this. So what did I just prove? Is the function differentiable? Yes, it is. So I do want you to take shorter methods to find your derivatives. They won't tell you to use the long definition. All right, with that, anything else that I wanted to mention? No, I think that's it. No, actually, I have a table. I wanted to mention. There it is. So I'm going to redo it with you. So, given that you have a function f of x, that function can be two things. You can either be continuous, or you can be not continuous. And if you're not continuous, we already said that there's 4 ways to not be continuous. What are the 4 ways? First, jump is one of them. Oscillating is one of them. Removable is another one. Infinite. Infinite, which is the same thing as a vertical asymptote. Alright, so we got that. If you're continuous, what do you know about differentiability? It can actually be, no, let's start with not continuous. That's easier. If it's not continuous, what do you know? Not differentiable. 100% derivative doesn't exist. Okay? But if you're continuous, you could be differentiable. But you could also be not differentiable. That's what we did today. So what are the 4 things that would not be differentiable? There were a total of 4. Corner, cusp, vertical tangent, but look, not continuous already showed up here, so we don't rewrite it. Why I do this, I want you to understand. If the function's differentiable, so you're actually looking at it backwards. If the function's differentiable, there's only one option. The function had to have been continuous. If the function's not differentiable, this is the trickier one, what do you notice? There's 2 options. You could have been continuous, you could have not been continuous. You want to be careful with that. Okay? On your sign charts, remember, we always say, if the function is not differentiable, we put our undefined. But if the function is not differentiable because it's got a discontinuity, we cross it out. This is a cusp corner vertical tangent. This is a discontinuity. You want to label your sign chart specifically that way so you don't forget. Focus. Stop looking at the wasp. I will close every window and trap it in here and then make it all riled up. No, it'll be fine. It won't do anything as long as you guys don't whack at it. All right.